All right, guys. So we learned what a population is, and we learned what a sample is. The population is a collection of all outcomes, all measurements, all counts, everything. The sample is a part of the population. So if the population is the citizens of the city of Dearborn, a sample could be a collection of 100 citizens, from the city of Dearborn. That would be an example of a population, a sample. We learned what a parameter is. Parameter is a number that describes a population attribute or characteristic. And a statistic is a number that describes a sample characteristic. For example, we surveyed 40 students at Henry Ford College and found out that their average age is 22 years. The 22, guys, is a statistics because it comes from a survey only of 40 students. But if I say we surveyed all the students at Henry Ford College and their average age was 22 years, the 22 will be a parameter because it comes as a summary from all students at the college. We learned the difference between a quantitative and a qualitative data. Quantitative is a number, guys, that you can add, subtract, multiply, divide. Qualitative is an attribute. An example for a quantitative: number of tables in a classroom. That's a quantitative. An example of a qualitative, guys, would be your favorite color. That's a qualitative. Your social security number is a qualitative. Driver license number is qualitative, although it's called a number, but it's not an actual number that you can manipulate. What else we learned? We learned the difference between descriptive statistics and inferential statistics. Descriptive statistics means describing data, displaying data in a graph, a pie chart, a bar chart, a line graph. For the stock market, they use line graphs. Inferential statistics use the descriptive statistics to make an inference, to make a conclusion about the population, make an inference. Usually, inferential statistics will not be given to you. You would have, to come up with that inference, and make a conclusion about the population from your sample. So you collect a sample and you analyze, the data in the sample and then make a conclusion about the entire population. And what else did we learn? We learned that there were 4 levels of measurements of data, which are nominal. Data at the nominal level is a qualitative data and cannot be ordered, cannot be put in order. For example, your favorite color. These are qualitative data and you cannot order them, like what comes first, what comes next, etc. Then ordinal. It's mainly, guys, qualitative data, but that can be ranked, ordered. For example, your letter grade, A, B, C, D. And then interval. Interval is a quantitative data where 0 means something. So it's quantitative data. The data can be ordered, ranked, but 0 means something. It's not the inheritance 0 that means nothing. And we decided, guys, when we met, that temperature was a very good example of data at the interval level. Then we talked about the last level, which is the most important one to us, which is called ratio. Ratio, the 0 means nothing. And we give a lot of examples under ratio: weight, height, money, age, time. It's all at the ratio level. And the last thing I did before we ended the meeting last Monday, we defined simple random sample. And I said the definition of a random sample is every member of the population has the same chance of being selected. And we agreed, guys, that the best way to do this is put, like, for example, if I want to select 5 students from a group of 30, just put the 30 names in a basket and select 5 names at random. Samples, to be reliable, guys, have to be random samples. If there is a bias, in selecting the sample, then there will be questions about the results, and the results, just would not reflect, just on the population if the sample is not a random sample. Okay, and so that's pretty much it, what I did last time, and I'm just going to continue from there, guys. So let me just move here. And we also, guys, looked what else did we do? The methods of collecting data, and we had 4 methods: the simulation, the experiment, observational study, and the survey. Survey and experiments are the most popular ways of collecting data. We defined a simple random sample, guys, to be every possible sample of the same size has the same chance of being selected. Okay. Now I'm going to show you some traditional ways of collecting data, guys, using tables. Like, let's say we have 731 students and we wanted to select 5 students at random. We don't have technology. We're not going to put the names in a basket because it does take time, but we do have a table, and I'm going to show you how to use this table to collect, to select, 5 names. I think we did that last time, but I'm just going to do it again. So if I give you a question like this, first of all, I will tell you where to start. So we number the students from 1 to 732. And remember, since 732 has 3 digits, all students have to have, 3 digits for their numbers. So 1 will be a 001, 2 will be a 002, 003, all the way to 731. So how do you select the names using a random table? The arrow is telling you start reading, just from here. So you just read the first 3 digits, guys, which is 719. Is 719 a number between 1 and 731? What do you guys think? Yes or no?
Yes.
Yes, so that will be selected. So we tell the students whose number is 719, you tell them you are going to be in the sample. Then we go to the next one. 3 digits, guys. 662. That's in the sample because it's less than 732. Then what about 738, guys? Would this student be selected?
No.
No, there are no students by this number. The highest number is 731, so no, we skip. Then we go read 3 digits, go horizontal. Now you ask me, why do I read horizontally, vertically? We'll tell you, we'll give you direction how to read it. So just read the next 3 digits. 650, it's in the sample. Look, if you think that there is no chance for someone whose number is 4 to be selected, you're wrong. Look here what we got. We got 004. This person will be selected. How many we are selecting? 8 students. So I'm going to go all the way through 8. We want 8 students. Look at the next 3 digits, guys. Number 53 is going to be selected. And then next 3 digits, 589. And 403, do we have 8 already? 1, 2, 3, 4, 5, 6, 7. Okay, one more, guys. And then 129. And this is how you use this table to generate a sample. We used to use this technique a lot, guys, before technology evolved. But now we have technology, we have the TI-84 that will allow us to pick, those 8 names in 8 numbers in no time. I can just tell the calculator, I have numbers from 1 to 731. Just give me 8 numbers at random, and you will get 8 numbers. But this is a technique. If you don't have access to technology and you have this table, this is how you use the table. But you need a starting point. Sometimes the starting point will be, guys, just close your eyes, put your finger somewhere, and then start from there. So that's a starting point. All right. Okay. Other sampling techniques. So the first technique, guys, we said it's a simple random sample where every member of the population have the same chance of being selected. This is very good way, just of putting people in a sample. Now, let me tell you the next sampling technique that we're going to talk about. It's called the stratified sample. Here's how a stratified sample work. The divide shouldn't be there. Here's an example. I'm going to give you an example just to give you a feel of the sample. To collect a stratified sample of the number of people who live in the Westridge County households. So the population is the Westridge County households. We divide the households into socioeconomic levels. So we divide them into areas. Group 1 is a low income area. Group 2, middle income, and group 3 is high income. So we divide the county into 3 groups. One group, all the low income people. Second group, the middle income people, and then the third group, high income. And then we go and select from each group and put them all together. That would make a stratified sample. So a stratified sample, guys, you divide the population into subgroups, and then you go and get members from each group and put them together to make your sample. That is what stratified is. So divide the population into groups with, they call them strata, and then select a random sample from each group. Look here, we selected 2 here. Why did we select the 3 here, guys? As you notice from this group, we've got 2 here, 2 there, but 3 there. Can you guys explain to me why?
It's more.
Exactly, because there is more middle income people. It makes sense. You have to be fair. If there are more people living there, you have to select more from the middle income area. And then you just take these 2, these 3, that's 5, and these 2, 7, and put them all together to make what we call a stratified sample. Now, let me give you an example of a cluster sample. Okay. You divide the population into groups. They call them clusters here. Look, like for example, the Westridge County. You divide it into zone areas, zip codes. 1, 2, 3, 4 areas. And then you go and take all the members who live in 1 zone area or 2 zone areas and put them in the sample. So you don't select a little bit from each zone. You just take the entire zone and say, this is going to be my sample. So divide the population into groups and select all of the members in 1 or more, but not all of the clusters. So here we divided, just the Ridge County, the county into 4 zones. And then we say that we're going to select the members of zone 1, all of them, and put them in the sample and make it what we call a cluster sample. So in the Westridge County examples, you could divide the households into clusters according to zip codes, then select all the households in 1 or more, but not all the zip codes. It could be all of zone 1 and all of zone 4, for example. You put them all together in the sample. There is an advantage and disadvantage of using using this. For example, guys, if this was about low income, middle income, high income people, that would be bad, you know, just to use a cluster sample. Because if zone 1 was only the low income people, then you left out, you know, just the middle and the high income people. But if it was about something that people, that all zone areas have something in common, then they're pretty much the same, you know, just then it doesn't matter, you know, just where you pick, whether you pick the entire zone 1 or entire zone 2, since they all have common characteristics. But for low income, middle income, and high income guys, I think stratified is better, because you're getting, you know, just from each income group, you're getting people from each income, so we have a good representation in the sample. Systematic sample. Let me tell you what a systematic sample. That's an easy one. Let me give you an example, then you will get it what a systematic is. Let's say I want to pick 5 students and I am in the classroom. Okay, and the class starts at 9:10. So I'll stand by the door. The students who walked in at 9:05, for example, will be in the sample. And then I say I will pick every third students thereafter. So I'll just count 1, 2, 3 until that students you are in. Then the next one who comes, that will be number 6, because 3 and then 6 and then 9 and then 12. So we just create a system, guys. Every 4th students who walked in, every 5th students who walk in, that's what we call a systematic sample. So you create your own system and how you want to collect, you know, just a sample and just follow it. And here is the definition here. Choose a starting value at random and then choose every kth member of the population. Kth could be 2nd, 3rd, 4th, 5th, whatever you want it to be. Okay, that's systematic. And then the last one, which usually we don't use much, it leads to bias. And let me give you an example of the systematic sample right here. In the West Ridge County example, you could assign a different number to each household, randomly choose a starting number right here, which shows this one as a starting number, and then select every 100th household. So we count 1, 2, 3, 4, all the way to 100, and then we get the next one. Another 100, and we get the next one, and so on and so forth. You can think of it every, for example, third, 1, 2, 3, that's a 1. 1, 2, 3, the third. Okay. Convenience sample. That leads to bias study usually. Choose only members of the population that are easy to get. Often leads to bias study, and it's not recommended. Let me give you an example of a convenience sample. Let's say, guys, I want to survey students on the distance that they commute from home to school. And I pick, and it's winter time, it's snowing outside badly, it's very bad, and only 5 students showed up to class out of 25 students. So I tell those students who showed up to class that I'm going to make you my convenience sample and you're going to do that survey for me. That would lead definitely to bias, guys, and probably it would lead to results that don't reflect on the entire group. Can you give me, guys, one example? Why do you think, you know, just this survey about the distance that students commute from their home to school with those 5 students definitely is going to lead to biased and wrong results? Why would that be the case? Any ideas? Well, why do you think that? What is it?
Because some students may commute further.
Okay, you're getting close there. You know, those 5 students who showed up to class probably live very close to the college, and that's why they managed, you know, just to make it to the class. And if they live very close, the results of the survey, it's going to say that my distance don't commute, you know, just long distance to My students don't commute a long distance to come to school. And I'm going to make an inference that the students live at a close distance to the college, which is a wrong inference, guys, but it is based, just on that convenience sample. So usually we should avoid, just those types of samples. But do statisticians use convenience sampling technique? Yeah, sometimes they do it, guys, and you wouldn't know. It's all done in the background. You don't know that. All right. Okay, let's see, guys. So we have simple random sample, we have a stratified, we have a cluster, we have systematic, and we have convenience sampling techniques. I'm going to give you those two examples, guys, and you tell me what sampling technique is being used. If you like me, let me write them down. So simple random sample, stratified, cluster, systematic, and convenience. Okay, let's see, guys, what you think here. You are doing a study to determine the opinion of students at your school regarding stem cell research. Identify the sampling technique used. You divide the student population with respect to measures and randomly select and question some students in each measure. So we divide our population of students into measures: chemistry, biology, language arts, math, social science, criminal justice, etc. And then we go to each measure and we select some students from each measure. What would that be, guys?
Stratified?
Yes. It is indeed stratified. You are absolutely correct. Any questions about this, guys? Okay. Let's see, number 2. You assign each student a number and generate random numbers. So you just, you can generate number using the calculator. So you then question each student whose number is randomly selected. What do you guys think?
That's systematic.
I didn't create a system. I thought the students is going to say a system. A system would be if you say, I'm going to pick every third, every fourth. We said we asked some technology, whatever, to pick some random numbers for us from the numbers we assign to students. Let's say I have 100 students. I can tell the calculator I have students from 1 to 100, and then pick 5 names for me or 5 numbers for me.
Okay, that's random.
That's random, exactly. That's a simple random, guys. And this is the best way to select a sample, guys. It's a very good way to select a sample. If it doesn't tell you we're picking every 4th, every 5th, every 6th, then, guys, it's a random sample. Let's see if we can do some more here. I'm going to do some more exercises. Just 1 second. Okay, tell me what sampling technique is being used, guys. It's on in the book, it's page 25. Number 23, selecting employees at random from an employee directory. Researchers contact 300 people and ask what obstacles, such as computer problems, keep them from accomplishing tasks at work. Is it a simple random sample, stratified, cluster, systematic, or convenience?
Simple.
Simple random sample, yes. And the word, guys, the key word for you guys to catch this is the random. He says random. That's a good word in statistics. Let's see, 24. Pay attention to 24. Questioning university students as they leave the fraternity party, a researcher asks 463 students about their study habits.
Convenient.
Yes. You're asking students who were partying, guys, about their study habits. So that's convenience, and only in one location, you know, you just went to that location. That's convenience. It's not random. Probably people who gathered at the party have one similar common opinion about the study habits. So that's what we call convenience. 25. After a hurricane, a disaster area is divided into 200 equal grids. So the population is divided in 200 pieces, grids. 30 of the grids are selected, and every occupied households in the grid is interviewed to help focus relief efforts on what residents require the most. So we have 200 grids, guys. Each grid has so many homes. And then we select 30 grids, and everyone in each of the 30 grids was interviewed and put in the sample. What would that be?
Stratified.
Stratified, if you have 200 equal grids, you would have to go and select from each grid, members of each grid.
Cluster.
Here cluster, exactly. That is a cluster sample, because you divide the population 200 pieces, and then you take 30 of those pieces and interviewed everyone inside, you know, just each of the clusters. Because it says 30 of the grids are selected, and every occupied households in the grid is interviewed to help focus relief efforts on what residents require the most. Okay, let's do couple more. 26. Every 10th person entering a mall is asked to name his or her favorite store. What do you guys think?
What does it call it?
Not a convenience one, starts with S.
Systematic.
Systematic. Yeah. And then last one, 27. Soybeans are planted on a 48-acre field. The field is divided into 1-acre subplots.
No, but I'm in school, baby.
A sample is taken from each subplot to estimate the harvest. What do you guys think? So we have 48 acre, that's the population. Stratified, exactly, because we're dividing it into 1 acre, so 48 pieces, and a sample is taken from each piece, guys. That is a stratified sample. And if you ask me about 28, guys, I can tell you it's a random sample from calls made with randomly generated telephone numbers. 1,012 respondents are asked if they rent or own their own residence. Since it says the word random, guys, this is a simple random sample. All right. So this is a summary of chapter 1, as you can see. So you can have this handy as you do your homework. It summarizes everything that we have done, guys, so far. So I put it toward the end. Levels of measurements, nominal, ordinal, interval with examples. Methods of collecting data. How do you do that? Observational study. This we didn't talk about, so you don't have to worry about him. I just put him there for more information. Whatever we discuss, that's what you will be assessed on, guys. I just want to explain, tell you what this means in statistics, which is very important in statistics. It's just for your own knowledge. Let me give you this example, guys, and tell you what a confounding variable means. Take this example. A coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined, guys, whether the increase is due to the remodeling of the shop or because the new mall has opened and there is more traffic now, just in the area. The coffee shop owner did the remodeling thinking that this is going to increase the business. But if the business increases and there is a new mall that just opened there, you wouldn't be able to tell if the increase, in the business revenues is due to the remodeling or for some other reasons, just because the new mall has opened. And when there is a situation like that, it's called a confounding variables. They occur when an experimental cannot tell the difference between the effects of different factors on a variable. And the shop owner will never be able to tell whether the increase was due, just to the remodeling only or the increase in traffic, just in the area as a result of opening, just a new mall. That's what so a confounding variable is a factor, guys, that pops in without you being aware of it and can affect, just results of your study. And it's something sometimes you cannot control. You cannot control, just whether this mall, is going to open or not, just in the area. For the coffee shop owner, it's a good thing, but it could be sometimes, just it does cause, just harm more than good in some situations. You know what a placebo is? It's not a treatment. It's usually, just a placebo, in medical experiments, it's a sugar pill that patients are given. Sometimes you don't tell them, that they're being given, just a placebo. You just keep them under the impression that they're taking a medication, but where in fact, they're not taking anything. Sampling technique, guys, I summarize all of them right here. Random, simple, stratified, cluster, systematic, and probably I didn't put the convenience sample there, but yeah. And that's it for chapter